These are the notes for Module J, Unit 1, Lesson 1. The topic is waves. The essential question says, what are waves? And the explanation says that by the end of this lesson, you should be able to distinguish between or tell the difference between types of waves based on their medium and the direction of the motion. The picture here illustrates an ocean wave, which is one of the types of waves we'll discuss in this lesson. You have two learning targets. The first is I can explain the difference between longitudinal and transverse waves. And the second is I can explain the difference between electromagnetic and mechanical waves and give examples of each. There are a total of 6 vocab words in this lesson: wave, medium, longitudinal wave, transverse wave, mechanical wave, and electromagnetic wave. You don't need to do separate definitions in your notes, and you'll notice there's not a place for them because these are the things we focus on in the notes today. So you should get all of the information you need in terms of definitions as we go through the notes. The first statement in the notes is a fill-in-the-blank statement. Waves are disturbances that carry energy. They do not carry matter, and that's something I'll explain more as we go through the lesson. The first type of wave we'll look at is a longitudinal wave. In a longitudinal wave, the disturbance or the disruption, the way matter is moved, is parallel to the direction of the wave. So it moves back and forth in the same direction that the wave or the energy is traveling. I would like you to put a definition in your notes and also an illustration. You can either find a picture online in Google Images, like the one I have here, or you can draw your own picture. In class, we used a slinky to illustrate the types of waves. So in a longitudinal wave, I pulled the slinky back toward me and let it go, and it bounced back and forth between me and the person who was holding the other end of the slinky. So the slinky was moving back and forth between us, and the wave was moving back and forth between us. The parts where the slinky or the wave are closer together are called compressions. When you compress something, you're squishing it together. And the places where the slinky is more spread out, or the parts of the medium are more spread out, that's called a rarefaction. It's kind of a funny word, and it's one you'll just have to memorize. The second type of wave we talked about and illustrated with the slinky is a transverse wave. In a transverse wave, the particles in the medium move perpendicular to the direction of the wave. So when we made a transverse wave with the slinky in class, I had a student hold the other end, and I waved the slinky up and down. So the wave was moving back and forth between me and the other student, but the slinky moved perpendicular, either up and down or side to side. Again, you should find an illustration of a transverse wave. You can find an image on Google, like this one, or you can draw it in your notes. But a transverse wave has high points that we call crests and low points that we call troughs. So when the slinky was moving up and down, the highest points of the wave were the crests, the lowest points of the wave were the trough, and then in the middle is something we call rest position, or here it's labeled equilibrium, and we'll talk more about that in lesson 2. A word you've heard me use already that you need to know is medium. The medium is the matter a wave travels through. So particles in matter vibrate as the wave passes, and that medium can be any of the 3 states of matter: a solid, a liquid, or a gas. You should include some examples in your notes. Water is an example. Obviously, waves travel through water. That's what makes waves on the lake. Bricks, sound can travel through a solid object. That's why when you're in the classroom with the door closed, you can hear things happening in the hallway. And then air is a medium. That's how you can hear my voice talking. I'm creating sound waves that pass vibrations through air particles closer and closer until they reach the little bones in your ear, and they pass the vibrations onto your bone, the bones in your ear, and your brain translates those vibrations into sounds and words that have meaning. So the medium is matter, something that has mass and takes up space. It can be a solid, a liquid, or a gas. Then we've got 2 more types of waves to look at. A mechanical wave is a wave that has to travel through a medium. Water is an example of a mechanical wave. If you don't have water, you can't have a water wave. Sound waves are mechanical. Sound can't travel through empty space. That's why astronauts have to wear the bubble helmets and use radios to talk to each other. If they didn't have their helmets on and they just shouted at each other, they couldn't hear each other because there's no matter in space. Earthquake waves are also mechanical waves. Without Earth's crust to travel through, the waves die off. In contrast, electromagnetic waves do not need a medium to travel. Microwaves, light waves, radio waves, and X-rays are all examples of electromagnetic waves, and that's why we can get sunlight and heat here on Earth. because the light and heat from the sun are able to travel through empty space. They don't require a medium. Then lastly, there's a question in the digital lesson that is also recorded in your notes. I'd like you to think about it for a minute and then answer it. How is the motion of particles in the medium different from the motion of the wave? In class, I had some illustrations with the slinky to show this. We talked about it. There are two big ideas you need to record. The first is that waves transfer energy, not matter. When you fish and you cast, your bobber goes up and down as the waves pass. It does not travel all the way into shore with the first wave. And that's how we know that waves transfer energy, not matter. The water waves do not carry your bobber all the way into shore. And then the second big idea you need to include is that particles vibrate in place as the wave passes through the matter. So the water on the lake moves up and down as a wave passes. It doesn't get carried to shore. With each wave that passes, it goes up and down, but it stays in the same place. It's currents in the water and wind that carry your bobber and water along through a body of water, not the waves themselves. Those are the notes for Module J, Unit 1, Lesson 1.